Good night, welcome guys. So my name's John Martin, and I'm here to tell you a little bit about weather, and in association with PredictWind, we've also got a guest today as well. So Adam Wade from Marina, put your hand up, Adam, and I said one hand. Okay, and you've also got Joe here as well. Is Joe back in again? Or there you go. Hi, Joe. And welcome to New Zealand. It's slightly cooler here than it was in Fiji yesterday. So Linda and I flew in yesterday morning and left Fiji at 32 degrees and landed at Auckland Airport at 16 degrees. It was a little bit of a culture shock. So, how many people have enjoyed the summer here with the fabulous weather that New Zealand's been putting on for you?
No one.
Okay, nobody's put your hand up? Dear oh dear. Okay. We've had a few people say you lied. I told them that New Zealand is a fantastic place to come down for. We stayed up in the tropics and they came down here, and guess what? We had fabulous weather over summer up in Fiji, so it's been rather nice. So everybody be aware that at the moment we've got a rather what you'd call chaotic weather pattern, and have had for the last probably 4 or 5 months. So cyclone season in the tropics is usually pretty active. We've had a couple of really nasty, or 3 really nasty ones, Gabrielle, Kevin and Judy, that have come down, and Vanuatu has been particularly badly affected with that, and we were only really 500 nautical miles away from that storm when it came through. So category 5 plus. So they're talking about changing the scale of the cyclones to include some of the more dramatic cyclones that we've seen over the last 2 or 3 years. So weather in New Zealand has definitely not been a standard weather pattern for the summer. Generally speaking, the high pressure systems come down from the tropics. They migrate south from over the summer, and they haven't done that this year. So we've had odd weather throughout the whole of the South Pacific. Typical La Nina year, and we've had La Nina year for the last 4 years, or 3 or 4 years. So we're moving towards the Southern Oscillation. Who knows about the Southern Oscillation? Is there any experts here in the Southern Oscillation? If so, come on up and take the mic. No? Okay. So ENSO, or El Nino Southern Oscillation, is moving into the El Nino stage now. The brisk trade winds that we've had in the South Pacific over the last 3 or 4 years are going to subside, and we're going to see a much lighter trade wind situation this year. However, one of the problems with having a light trade wind year is we get water patches, or water that gets warmer and warmer. So we've already got warm water in the Coral Sea at the moment, and that water is starting, because the trades have been very calm over, in fact there's been no trades over the summer period at all. It's all been northerlies. A lot of that water is now cascading back across the Pacific, and who knows people that have come out of Panama this year? Anybody know people that have come out of Panama? So one of the problems with the boats coming out of Panama at the moment is that there's been no air at all, no wind at all in the Gulf of Panama, and a lot of the boats have been finding a counter-current instead of the currents running from east to west. The currents have been going west to east, particularly north of the equator. So a few boats got routed that way by somebody, and they've had a dreadful time getting across to the Marquesas. So no trades means that this hot water that was in the Coral Sea is now starting to move back across. So next summer we'll probably see much higher temperatures in the Southwest Pacific, and that's going to mean more activity. And this year most of the activity was in the west, and next year I'm picking it's going to probably be centered somewhere over Toma and places east, even further east than that. So it could be a bad year for cyclones, and there's really only one place in the South Pacific, or two places in the South Pacific that are any good. There's a very good boatyard in Vavahu and Tonga, if anybody wants to pull the boat out there. But by far the best place, we've actually got the speaker from there here today. Adam will tell you a little bit more about this later on, from the Marina in Fiji. So otherwise it's New Zealand or on to Australia. So that's what I'm picking at the moment. So this is the anomaly chart for the world oceans. So anything in blue is colder than usual. Anything in red or orange is warmer than usual. So as you can see up in the Coral Sea here, we've got some very warm water. We've got even warmer water off the bottom of Vanuatu. That's Vanuatu just there. And a very warm patch here off the east coast of the South Island of New Zealand. So very unusual weather patterns. The other one that's very unusual, can anybody else tell me what in the southern hemisphere is very unusual? A patch of warm water.
Well, the patch near the Falklands.
No, that's not the Pacific.
Oh.
The Falklands, yeah. That's over here.
Right.
Okay, so this patch up here. Okay, so normally we have the Humboldt Current coming up and bringing cold water to the Galapagos Islands up here. And at the moment, that black dot there means that the water is somewhere near 5 degrees warmer in that area than it usually is. So some significant changes to the atmospheric conditions in that region. So we've got some changes happening, and with the change from La Nina to El Nino, with the El Nino patterns bringing less wind, there's less cooling from well, you know full well when you turn the fan on. If you're hot, you get much better air, much better cooling from having a fan on. Same with the trade winds, so they're not blowing so hard at the moment, so therefore we're going to see warmer temperatures this year in the tropics. So moving along, that is currently the currents in the world's oceans. So quite interesting. So very hot water up in the tropical regions here, and very cool water down here as usual. But this area here is normally all flowing in this direction, with one very small part of countercurrent running the other way. So that's your normal ITCZ. Everybody know what the ITCZ is? The Intertropical Convergence Zone. And then we've got the South Pacific Convergence Zone. So the ITCZ normally spans right across the Pacific, and the SPCZ comes down quite often over Tonga and Fiji during the summer periods. So the SPCZ has actually just started to move north again, but that was taken the other day. Now, as you can see, there's no definition, or very little definition, between the SPCZ and the ITCZ, and Fiji here, and that's Tahiti, and as you can see, there's this area of what usually is the SPCZ over here, very much further to the east in the Pacific at the moment. So that was also taken just the other day as well, the Friday the 28th of April, what the weather forecast is for that date. And as you can see, there is a huge amount of chaos in the Southern Ocean at the moment. And this is our lovely little friend here that's coming down from the tropics again. So there's been a continuation of this. Now, those are still likely to continue. So we're seeing these pop up. During February and March, they were coming up almost once a week, and now we're getting about a 2-week pattern between the lows. My forecast for the South Pacific is that those are going to remain a feature in the weather for at least the next months. So We've already seen some changes in the weather forecast for the end of the coming week next week. Yesterday, if you'd had a look at the weather patterns for departure out of New Zealand, they were looking quite favourable, but today in the forecast this morning, a little bit less favourable. So the weather is very changeable, very unstable. And when we get instability, we also find two things happen. When we've got instability in the systems, we have a much bigger differential between the average wind speed and the gust wind speed. So, and it makes it very difficult to trim for both conditions. So there's a possibility of a pattern at the end of next week, which is rapidly disappearing, but that's the only one I'm seeing at this stage for the foreseeable future. So we'd like to welcome you to stay in Opua for a period of time. So as you can see, the forecast for last week, and that's is the gust forecast. So horrible gusty conditions. Anything in the black is terrible. So we've got the southern oscillation, which is one weather pattern or one weather event. We've also got the Madden-Julian oscillation. Now, does anybody know what the Madden-Julian oscillation is? Hands up if you've heard of this before. Okay, so only one hand. Okay. So the Madden-Julian oscillation is essentially an area or a band of stormy wet conditions that rotates around the world from west to east over a variable period. So the variable period is anything from 30 to 90 days to go right around the world. And you can forecast when some of the nasty weather is coming by having a look at the oscillation. You can get information from that from NOAA, and that's usually very consistent, except for March this year when the oscillation went backwards for a month. So it went from east to west and created havoc in Australian weather. So these are things that are almost unforecastable. So you have to have access to a lot of other information other than what you're seeing on the boats during passages. So as a professional weather router myself, we've got access to a lot of this information, and for the weather routing these days, it's taking 2 or 3 times as long to analyze what the weather is doing than it used to be. So all good. Now, why are we going backwards and forwards? Okay, so typical winter. Winter. I must have renamed that incorrectly. Okay, so there's summer, big high pressure systems, and they've dropped down over New Zealand. We haven't seen those weather patterns this year. We've seen the low pressures coming down from the tropics. We've seen these low pressures that are normally skipping underneath New Zealand down here. We've seen them coming up out of the Bight of Australia, out of the Tasman Sea, and coming over the top of New Zealand as well. So if we just go back to one for the winter time. So what we're hoping is that these high pressure systems will move back up, and because of the lower wind speeds up here, with this year we're hoping that we're not going to see this squeeze zone. We'll see that in a minute between the high pressure systems. The system that came across, the high pressure system that came across last week, how many people registered what the center pressure of that was? Anybody know what the center pressure of it was? 1032. Yeah, so 1032 is a very intense high pressure system. So what we're looking for when we're wanting to depart New Zealand is a high pressure system coming over that's between 1020 and 1025. Now, a little bit of that is affected by the how high the high pressure system, how far north the high pressure systems are, and what the center pressure is. So the higher the center pressure and the further north the high pressure systems are, the more wind you're going to get at the northern perimeter where it bounces against the intertropical low pressure system. Okay? So at the moment we're seeing very intense highs, which are normally summer weather highs as far as the intensity is concerned. So again, the wind on the front edges of them here is higher. The wind up in the tropics is higher at the squeeze zone. The squeeze zone, generally speaking, is between 18 degrees south and 22 degrees south. Your trouble is does not want to go forwards. Right, so here we are then with the highs here, squeeze zone at the top, and everybody knows that in the southern hemisphere the high pressures rotate in which direction? Clockwise or anti-clockwise? Anti-clockwise, and in the northern hemisphere? Clockwise. So it gets a little bit confusing for you folks that have come from the northern hemisphere. The other thing that changes is in the northern hemisphere, the high pressure off the west coast of the United States is virtually stationary. It moves up and down a little bit, moves sideways a little bit, but it doesn't migrate across from west to east. These high pressure systems here come from the Indian Ocean, come underneath Australia, and they migrate to the east, so west to east migration. Now that means that instead of being able to gauge what the wind direction is at any time on the high pressure system, if it was stationary, that would be the winds you always get. But what we're seeing here is these patterns here are moving across this way, which means that this wind that you got over here, when the high pressure system was here, when it gets over to here, it's now this direction. Okay, so you've got to factor that into your calculations for your passages as well. Low pressures, of course, are cyclonic down here, so they go in a clockwise direction. So again, nothing wrong with a low pressure system as long as it's as long as you're not near the center of it. The wind on the outside of a low pressure system is quite comfortable a lot of the time. Frontal bands, though, are the problem. So every low pressure system that comes across, this one here, you can see the frontal band here, and that frontal band will also be pulling air in from here, so that all the way down and round into the low pressure. See if it goes forward this time. So if you imagine a frontal band coming in here, you can see the wind directions here changing. This will be the frontal band. So there's a low pressure down here, frontal band coming up through here. You'll be getting northerly winds here, and then you'll get the westerly or southwesterly winds here that then flick in. So that the flick between here and here may be as little as an hour, and you can generally see that with a very dark cloud across the horizon. So that is a light or moderate front where you've got broken areas here and a cell in the middle, and that's a different pattern altogether. So what can you use to see that effect? Can anybody tell me? Radar's one. Yeah, radar's very good, but you can get much more advanced notice of that by looking at the Cape forecast, particularly on predict wind. So can anybody tell me what CAPE stands for?
Convective available potential energy.
So effectively, it's measured in joules per kilogram of air. And if you have a look at this one here, the CAPE measurement around this region as a whole is probably going to be 1200 to 1500 joules per kilogram. So if you're looking at the predict wind forecast for CAPE, you're going to see some cells, possibly some of them active, but they're spaced well apart, and they're avoidable. One of the things you need to know about a cloud like this is that this cloud may top out at 65,000 feet. Okay? which means that the top of the cell is not in the trade winds or in the wind that's on the surface. Surface winds are, generally speaking, only 1 to 2,500 feet in depth. So the cloud may not be, or the cell may not be moving in the same direction as your wind speed, as your wind that you've got down on the surface is. It may be going with the system, and the system, as we saw before, is rotating. So that might be going completely counter, and that's where your radar comes in. So if you have radar on board the boat, you can track the cells and avoid them that way. This one here, on the other hand, is probably close to 2,500 joules per kilogram. So if you see 2,500 joules per kilogram in the forecast for Cape, and if anybody know anybody in French Polynesia at the moment, the Tuamotus. Okay, so the Tuamotus, I've got to say, a large region of very, very high Cape at the moment, and a couple of boats that we've been routing for are saying that they're getting thunderstorms on a regular basis, lots of lightning coming out of rather than sheet lightning in the clouds themselves, they're coming down and landing in the water. And one particular boat said that they had a lightning strike in the bay they were in last night, in the anchorage they were in. It landed about 50 feet away from their boat. So if you're seeing that kind of level of Cape, try not to be there if you can. Okay. So what's my first storm tactic?
Run away.
Don't be there. Okay. With modern forecasting, there are ways of avoiding it, but you've got to be able to interpret the information that you're seeing, and also understand where to get the right information from. Okay. So we'll get rid of that horrible photograph. Okay, so satellite is one of the areas that we can do. We can get. This is actually a loop. So this is the El Dorado weather, Central and South Pacific and Australian water vapor loop. So that was taken. I did that 2 days ago. So that gives you an idea of the movement of the systems. Now, anything that's in purple, I go again. There we go. So anything that's in purple is vapor. That's very high vapor. So lots of vapor and lots of thunder. You'll probably find that there's thunderstorms up in this region up here at the moment. That's the Tuamotus roughly there. That patch. Okay. So you're seeing that sort of thing. The further south you get, you're not going to get the same heat in the convection. So it's the same with wind. If you see the isobaric gradient, does everybody know what I'm talking about when I'm saying isobaric gradient? That's the distance apart the isobars are on the weather chart. They're very close together. In the tropics, you'll get lots and lots of wind, whereas the same gradient down here won't have anything like as much wind in it. Okay, so there's a big difference between tropical gradient and Antipodean gradient. I can see you're thinking about that. What are you thinking about?
Why is Why is
Why?
Yeah.
Why? Because there's much further around the world up here than there is down there. Okay, the world is a sphere.
Oh, because of the projection.
Correct. Yeah. Okay. Very close. You want to come up and do this?
No.
Very good. I'm liking it. It's very good. Okay, so we've also got one more satellite to have a look at as well, which I've gone past or I've missed it. Okay, so I did a weather route for you to go to Tonga on the 1st of May, which is this coming Monday. And as you can see, predict wind is a little bit chaotic. So anybody like to leave on that particular weather window? No? Okay. So the other thing that we're looking at now, predict wind are also putting these caution signs in the equation as well. And there's all sorts of different cautions from gusts and roll and vertical acceleration and you name it, cape, etc., etc. So very good to know what to expect in advance. One of the biggest problems with your weather routing, however, is that if you want the predictions to be consistent with what your boat is doing, you need to have your polars in the equation correctly nominated. So there's a very big difference between a boat that's going to be averaging 7 knots, for example, to a boat that's going to be averaging 5 knots in a passage, and the way that the waves affect those, and the way that the gust and other things work as well. So one of the reasons we've got this one here is we have the currents. So that's very clever, actually. Get rid of it. Okay, so one of the things you're going to find down here, particularly at this time of year, when you're heading up to Tonga, is there are huge variations in the current around the region. So if you imagine this one here coming down this way, and this one here coming down this way are about 1 to 1.5 knots of current. That's 24 to 35 miles a day that you're going to lose if you're on the wrong side of them. Now, what we've found over the last 6 months with the weather routing is that the RTOFS prediction is much more accurate than the Mercator prediction. So it's also 10 times the size, so the likelihood of you being able to download that on a Meridian Go is negligible. But it can make a huge difference, particularly if the wind is against the current. 1.5 knot current will peak will shorten the period of the wave stand. Now, we just had this discussion earlier with another boat. A 2.5 meter wave might sound big. It's about the height to the bottom of those upper windows up there. But if it's at 10 seconds, it's basically just like a swell. If it's at 6 seconds and you're going into it, big difference. So yeah. So, but a 3 meter swell at 6 seconds would be ugly. So the other thing is that, of course, how many people have got catamarans? Fewer than the norm. How many monohulls then? Okay, and all those that didn't put your hand up, what have you got? A rowboat. So very good. Okay, so catamarans are very much more susceptible to waves forward of the beam than monohulls are. Would anybody disagree with that? All you catamaran owners? So your wave pattern or your wave forecast is very important for you as well. Monohullers, question. What are you comfortable going to windward on a passage? What angle to the apparent wind are you happy with? Anybody care to venture an opinion? 50? Cool. Okay, catamarans? Okay, you don't want to go to windward at all, is that what you're saying? Sorry, did you say something?
Can't go to windward. Say it a bit louder. No, can't go to windward.
I don't agree with that. A little bit of it depends on the catamaran, to be honest with you. So the longer the waterline length of any boat, the less the swell and the wind waves will affect you. So again, from your perspective of your polars, the more accurate your polars are, the more accurate the effect wind will be able to predict on your boat. Okay, so one of the things that we do is Ocean Tactics. So Ocean Tactics is a weather and routing service for cruisers, and I'll tell you a little bit about why we do it. I started off and got a very well-known New Zealand weather router to route us for our very first trip in 1995. We ended up having an absolute horror trip, which fortunately Lynn and the kids flew up with my crew. One of my crew stepped off the boat, jumped onto the shore and bent down and kissed the sand. That's how glad he was to be on dry land again. And I said to Lynn when she arrived that year, if we're going to do this again, then we need to do it better. And all of our sailing has been around the Southwest Pacific. We've been doing it now for the last very nearly 30 years. And since then, we've been up and down to the islands over 40 times, and our total around the South Pacific is about 130,000 nautical miles in Windflower, our boat. So in all that time since our very first trip, Lynn's been on the boat every time, so she claims it's actually her being on the boat that means we've had a good passage, but we have not had a bad passage since then. I say it's because I started learning a little bit more about the weather and the systems and how they form and how they react in different situations. And so anybody that's going up to the islands this year, if you want to engage us, we'll give you just send an email to admin@coastalnoffshorecruising.com, and we'll give you a link to go to the weather routing page. A lot of information there as well, so go for that. The other thing we do, which if you give me 10 seconds, talk amongst yourselves quietly, and I'll be right with you. Does anybody know what it is I'm about to show you? Can anybody guess?
Do you know what it is yet?
I know what it is. That was rude.
That's Roe Paris, yeah.
That's what
Right, so we'll put that there for a second and turn this off. How many people are going to Tonga, Fiji, Vanuatu, New Caledonia? Right. Okay, so this is the Sail Fiji Cruising Guide, and it's on app. It's available on the iOS platform for iPad, and it's also available in a slightly less detailed version on the Android platform as well, both Tonga and Fiji. But if you give you a quick lesson on it. If you tap any of the routes or any of the magnifiers, it takes you to a different area, a different thing, so you can zoom in and out and get more information as you go. Tap a route, and it brings up what the route is with all the waypoints and a description of the route. So if you go down into the Lao group, for example, Honolulu, you get all the information you need. So we'll go tap there, takes you down to more detail, and if you want, there's also a lot of photographs of everything as well. So that's a 10-second look at Sail Fiji, and that's available through the App Store or the Google Play Store. The App Store is one app that covers the whole country and all the information. The Android one is 3 separate apps: the planning app, the Western and the Eastern apps. So it's all in the app, except you don't have to go back. You can be down at the bottom of the Lao and get 98% of the information. There's one thing that we don't have that's in the apps. It's what we call Sky View, which is an overhead view of in video format of all the various different places. So do that before you disappear down into the Lao. But you can also download those videos as well and watch them later. Okay. Cool.
We used it last year just to say that it was really good.
Sorry, say that a bit louder.
And we didn't pay him.
You do, are you? I think you just earned yourself a T-shirt. So come and see me afterwards. The only thing about it is you have to put it on. Excellent. Any other questions? Any questions about weather? Any questions about the apps or anything else like that? So yes. Sail Fiji, yes, indeed. No, it will not come up on a phone. Okay, it's designed for tablet only, so an iPad on the iOS platform or a tablet on the Android platform. And your Android version, your tablet needs to be Marshmallow operating system or later, which I think is Google 7. Are you Android or iPad? Yeah, of course you got an iPad when you got the boat, didn't you? Okay, so the iPad version, because it's about 10 to 1, 10 people buy the iPad version, one person the Android version. How many people are Android here? I can't see any hands. That's excellent news. Yeah. Lynn is Android.
We had this guy on the boat. I'm Android, he's iPad, but we both have Mac computers. So.
There you go. Okay, any questions? Yes.
So just kind of, thinking about the route up to Tonga.
Yep.
So I know coming down, we were kind of, the warning really was to try and get in between two lows, roughly. I know this is summarising it all, and I'm just kind of warnings really for going up. So you said that there's usually like a 2-week gap between two lows going down. So
no. What I said was that there's a gap at the moment between tropical lows coming out of the tropics and heading south. Yeah. So can everybody hear me? Are you hearing me up the back? Okay. So the question was the timing between lows. Now I'm going to answer that in two separate bits. So the first one is the tropical lows that are coming out of the tropics and heading south during February and March are coming down to about a weekly rate, which was giving terrible weather down here in New Zealand. That's slowed down now, and it's been 2 weeks since, or will be 2 weeks hopefully, since the next one as well. So those are tropical lows. They're nasty little lows, so you want to be very careful of them. But the other ones are the lows that go across the Southern Ocean. Okay, now those will have a frontal band and a tail, and those lows in the Southern Ocean are what separate the high pressure systems. So you'll have one high pressure, low pressure, high pressure. High follows low, follows high. Okay, and at the moment, summertime, the period between those the systems moving through is around about 7 to 8 days. As we get further into wintertime, the period reduces, and it might go down to as little as 4 or 5 days, high to low to high. You follow that? Okay. So coming down from the tropics is a little bit more difficult than going up to the tropics. One of the reasons for that is that, generally speaking, except for these low pressures that are forming in the tropics, it's much easier to come out of the tropics with the trade winds blowing to come down, much easier to go up to the tropics where the trade winds are blowing and go through very quickly the systems that are coming through down here. So you can get above them quickly, whereas coming down from the tropics at the end of the season, you've got nice weather that you start off with. So that might be 2 or 3 or 4 days, and then you come down to the worst weather as you're getting further south. So if you've started the passage off looking at an 8-day forecast or 10-day forecast, then it's very difficult to pick where the systems are going to be 8 or 9 days in advance when you leave the tropics to come down to New Zealand. A little bit better going up to the tropics in this time of year, because we know when the systems have gone through, when we've gone from high to low, back to high again, when the frontal band passes through here. So if the frontal band passes through here, then the next thing you're going to see is a high pressure system coming through, and that's when you want to go on what you want to go on. But at the moment, what we're saying is that that's not the only thing you've got to watch out for. We've got to watch out for these little lows up in the tropics, and those are the curly ones. So what happens then is good weather routing comes into play, putting the boat in the right place to either avoid systems that are coming or to put you in the correct place for wind in a week's time. Okay? And that's the trick. That's the real nub of weather routing, is to make sure that the boat is in the right place a week from now. Okay.
So you can kind of predict then what might happen in a week by looking at those tropical
Correct.
alerts coming
Yeah.
through.
Yeah. We get a little bit of notice on that, and we're also watching the water temperatures. We know where some of the hot spots are, and the one that's coming down now was forecastable. And if you had a look at the at all of the systems that have come down over the last 6 to 8 weeks to 2 months, they've all followed a pre-described course, whereas some of the ones that are formed in the tropics before, like Cyclone Winston, for example, went east to west or west to east, and was completely unforecastable. But because of what we know about weather now and the amount of information that we're able to garner, we're seeing much more conclusive evidence of where these systems are going to be going, because we know what causes them to move. Okay. Yeah.
And that's that knowledge what you're talking about, that's not incorporated in the models like the European model or the
One of your biggest problem with the models is, and I've had this discussion with people before. A lot of people ask me, why does Predict Wind do 5 or 6 or 7 models? And the reason being is that if all of the models are in agreement, then you can have very high confidence in the weather. If the models aren't agreeing, then the confidence level drops dramatically. I asked a group like this a little while ago, how many models do you guys look at? How many are you looking at every day before you're getting ready to go on the passage? 3, 4, 4. I had one guy say, I get 20. I look at 20. I said, you can't possibly look at 20 and get any consistency on what the weather's going to be. He said, I don't need it. One of them will be the weather I want to have. Okay. You won't get a job as a weather writer, sorry. So it's consistency in the models is what you're looking for. So if you've got 4 models, then go for that. Also, on Predicted Wind, you can also get validation. So if you go down to on the Predict Wind website only, if you go down to Tools, and just below Tools, you'll see Validation, and that will tell you which of the models has been more accurate historically over the last month. And that's some quite interesting information to look at. Now, that's based on observations at a specific point. So if you're going to travel from here to Tonga or Fiji, then the validation for Fiji or Tonga may be quite different from what the validation is from a weather source down, or from an observation source down here. Am I baffling you with science at the moment, guys, or am I confusing you? No? Okay, good. Any other questions? Yeah. Well, I'll take this one over here and then come back to you. Yeah.
Yeah, just on the app itself, is there like rating that allows to see how accurate or how much the models?
Not on the Predict Wind app. You'll have to go onto the website, or the web version of the Predict Wind to do that.
But is it going to say, for example, okay, 90% of the models say the same thing, or is it just going to say, okay, this model has been ranked for the...
Yep, so very good question. So what it does is it ranks all the models, okay? So you'll get a percentage. So let's say ECM is the top model on this particular observation. It'll say it's been right 68% of the time. And then you might go down to the bottom where it might be UKMO or Spire, and it says 4% right. Well, you're not going to trust that particular model at this time. And the models can be varied as well. The models are always constantly being tweaked. So every time they tweak them in the algorithms, you get a different result. Or you don't, but UKMO or Spire gets a different result. And if that result gives them a higher rating on the validation, then they keep that algorithm change, and they consistently are getting better and better and better at the forecasting. That answer the question? Cool.
So just the other thing I was going to ask really was, from your experience then, is there a general type of sailing that generally happens from here to Tonga? Like, I know we've got those different wind directions when we came down, but I was wondering whether it's sort of thing you can kind of expect to go up, or is that just too unstable?
Yes, it is, but provided you do everything right on that passage. In other words, you've got to be active in getting a good passage. It doesn't just happen by accident. Well, it probably does occasionally, but it's like, you know, putting 100 monkeys in a room, they'll eventually write a novel with typewriters. If you just sail directly from here to Tonga and you leave on any specific day, no particular knowledge of what the weather's going to be, you might ace it, but the chances are you probably won't. So it's a mixture of departure planning and passage planning. So departure planning is leaving on the right date, and 3 days can make a huge difference in the quality of the passage you get. And with passage planning, that's making sure that the boat is always in the right place. And if that means taking a big zig or a zag in order to do it, then why not? I'll give you a classic example of that. We were sailing up to Tonga with the fleet a few years ago, and we decided that we were going to stop off at Minerva Reef. So about halfway up, I looked at the weather on the predictions, on the forecasts, and said to everybody by email, I said, wind flower is turning 30 degrees to starboard, so that we put a little bit of easting in, because the high is moving through faster than we thought it was going to. And all the boys and girls that were in their lovely racing type boats, the wee fast boats, said, "Oh, we got a wind, we're fine, we'll be fine." Well, wind flower beat them into Minerva, because we had gone to the east. We'd sailed maybe 60 miles further than they had, but we caught, when we tacked over, we were beam reaching or tight reaching into Minerva Reef, whereas they were dink, 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 dink to Minerva. The other reason was we got in an hour before dark, and were settled at anchor before it got dark. They arrived an hour after dark, and there was no way they were coming through the Minerva Reef pass to come into anchor until the morning. So they spent another night out at sea. And that's purely and simply putting the boat in the right place for what's coming. Okay? Cool. Questions up the back? Or somebody had a hand up a second ago. Or is that like an auction? You just bought the property, man? Yeah.
I've got a question.
Up the back first. Sorry, pardon me.
I was just going to ask, would you, I know we had really unsettled, unpredictable weather this summer.
Yep.
Is it that you were looking forward over the next month, or when you're looking to get north?
Yep.
Would you say that you're going to have to grab the window comes to grab it, or is it a case that you would expect to still see some reasonable?
No, there is one thing that everybody in this room needs to take a lesson from the girls, and that is patience. Okay, girls are much better with patience than boys are. So, oh, really? Oh, that's the opposite in your relationship, isn't it? Okay. We gotta go. We are not going. There you go. Okay. So patience in departure planning. Patience is everything. It really is. And the fact of the matter is that regardless of what's happening with the weather globally, there will be a weather window, and there are telling factors of what is going to be a stable weather window before you leave. So, we used to run. Lynn and I were running rallies up to the islands for years, and as we got further into the late 2015, 16, 17, 18, the length of time that we spent waiting for a weather window was getting longer and longer and longer. Okay, and if you were scheduling the rally to go out on the 1st of May, the worst we had was the 6th of June. Okay, now you can imagine 30 odd boats, the kind of pressure that me as the weather rider was getting. Don't go, don't go. Half of them went. So half of them decided, I've got a crew problem, I have to get my crew back to New Zealand, they've got flights, etc., etc. And some of the boats got absolutely hammered on the way up. So we waited until the 6th of June. So if Windflower is going to be leaving the country, then it's time to go. But unfortunately, Windflower is already in Fiji.
But there doesn't come a counter where, like, I suppose in the back of my mind, it's like Queen's birthday storm if you leave it too late. So it's not a.
We took Windflower up to Fiji last year in August, and had a beautiful sail up, absolutely beautiful sail up. Okay, that's just, you're the second person that's asked that question today, so it is what on people's minds. Yeah.
But we've also had the opposite too, where you have to have patience, but you should be prepared, because we had one situation one year where it was all turned to custard and we weren't going to go, and then a weather window opened up at enough time to get far enough north to not get hit, and we had an absolutely wonderful sailing. So you've got to be ready, but you've got to have patience. I know it sounds like a contrast, but you've got to be able to do that and be prepared that if it opens up and it's right for you,
Go. Yeah.
you can then do it.
Okay, so any other questions? One more here, and that'll be the last one, because we've got Adam to hear too.
I've got one question about a picture from the Southwest Pacific routes in
All right. Yep.
the sky.
Yep. Yep.
And I'm looking to go to Vanuatu
Yep.
via New Caledonia.
Vanuatu via New Caledonia? Wrong way round.
Well, there isn't a route
What, to Vanuatu?
from New Caledonia to Vanuatu. There's one coming back.
Yeah, that's what I'm saying. Going from New Caledonia back to Vanuatu, you've gone the wrong way. You're going a zigzag. You're doing a zigzag instead of a zag-zig, or one vice versa.
Yeah.
Yeah. Okay, so that's why there's no route. Okay. So, to be honest with you, if you're coming out of Havana Passage and going to Vila, you can normally go either way. You can go north to Vila from Havana Passage if you want to. Okay, it's going to be a little tight on the wind, but it's also tight on the wind coming back the other way from Vanuatu as well. So just if you're going to do that, make sure that the wind is in the southeast instead of the east. Okay, and make sure that you've got enough time to get to Vanuatu before the high pressure departs to the east and you get the northeasterlies on the back of the high. Okay, follow that?
Yeah.
Okay, either that or just use me as a weather radar, one of the two. Okay, so Adam, come on up and I'll connect you to the.
If you just leave that on, just one quick plug.
Okay, so in this photograph here.
Okay.
A little bit further away from that. Down right here.
Back to Anthony.
Yep.
Is that good, everybody? Okay, so just a quick introduction. My name's Adam. I am the general manager of Marina in Fiji, and I've been in Fiji for 38 years. And I was never much of a sailor until I started running the Marina. But this is our family property out in the Lau Group, and I just recently bought a yacht, and everybody told me that going from VT level out to the Lau Group over here is very, very difficult to do. But I'm based over here, and our family property where that photo is over here. So I called up John and said, I was thinking about going this way. And he's like, don't do that, because I've got a 3-year-old and a 12-year-old, and I wanted to make it as comfortable for them as possible.
And a wife.
And a wife. That was probably the more important thing. So he said, why don't you go from Bunda to Raki Raki, which is easy within the reef, takes about 7 or 8 hours. Spend the night there, wait for a nice weather window, and go from here to Sabasol, all day sailing. So that took 12 hours, and then wait for another weather window, go over to just behind Taviuni.
Yeah.
We stayed in Horseshoe Bay.
Yeah, Horseshoe Bay, yeah.
Yeah, lovely spot. And then we waited for a weather window and came down there. So 4 days, all day sailing, all easily done because we had his app. So well done, John. John created it. John and Lynn created this, and it is a wealth of information, well worth it. It's got all the bays, all the anchorages, all the waypoints. Definitely check it out.
I'm just giving you a wallet out of that.
You owe me one beer.
Done.